practice prob for honors physics by Liz. We're going to be looking at a block and how it slides. Here's the problem. A 0.41 kilogram block slides from point A to point B along a frictionless surface. When the block reaches point B, it continues to slide along the horizontal surface BC when a kinetic frictional force acts. As a result, the block slows down, coming to rest at point C. The kinetic energy of block A is 37 joules, and the heights of A and B are 12.0 and 7.0 meters, respectively. Part A. What is the kinetic energy of the block when it reaches point B? Part B. How much work does the kinetic frictional force do during the BC segment of the trip? This problem is very wordy and a big problem. Let's break it down by looking at a diagram. If we take a look at this diagram here, we can see what the problem was trying to illustrate in its words. So first we have point A over here, and the height is 12.0 meters. And then the path of the block is going to slide down to point B over here. And you can see that the height here is 7.0 meters. And then it goes across a horizontal surface, which is right here, from point B to point C. And the height stays at 7.0 meters because it is horizontal, so the height is not changing. Next, we need to write down what was given in the problem so that we can start solving the problem. So the problem told us that the mass of the block is 0.41 kilograms, and it also gave us the kinetic energy of when the block is at point A, which is 37 joules. And then here in the picture it's illustrated that we have the height at point A and at point B, so we can fill that in at 12.0 meters and 7.0 meters. And what we're trying to solve for, part A of the question was asking, what is the kinetic energy of the block when it reaches point B? So we're unsure of that value at this moment. So what's next? We have the kinetic energy at point A, which is 37 joules. And we're trying to find the kinetic energy at point B. But how will we do that? Let's find out. So we're going to need to calculate the total energy to be able to find the kinetic energy at point B, because energy is conserved throughout the entire time that the block is moving. So if we start out by finding the potential energy at point A, we have our equation for potential energy, PE equals mgh, and so we're going to solve for PE. So we have PE equals, in the problem it said it was 0.41 kilograms times 9.8, because that's always G, and then the height that was given in the problem is 12.0. So you can pause the video and multiply that out for yourself if you would like to. And you can see that when we find the total PE at point A, it is 48.216 joules. So now we have to use that to find the total amount of energy. So we already had the kinetic energy at point A, which was right here. And then if we add that to the potential energy at point A, we're going to get the total energy at point A. So we're going to do KE plus PE equals E total. And then just substitute that, 37 plus 48.216. And that is going to equal our total energy of 85.216 joules. So now that we found the total energy, we can use that to calculate the kinetic energy at point B. Since the total amount of energy is going to be conserved, we need to find the potential energy at point B, and then we can solve for the kinetic energy since we have the total energy. So in order to find the potential energy at point B, we're going to do the same thing we did for point A, and the only thing that changes is the height because the block stays the same weight and the force of gravity is always going to be 9.8. So if we plug in for our PE equals mgh, and then PE equals 0.41 times 9.8 times 7.0 this time, as given the height in the problem. And then when you solve that, you'll find the potential energy at point B, which is 28.126 joules. So finally, we are ready to solve for the kinetic energy at point B. So we know that the energy total is going to equal PE plus KE. And we also know that energy is conserved, which means that the total amount of energy at point B has to be the same as the total amount of energy at point A. So if we take our answer that we just found previously for the total energy, which was 85.216, and we're going to set that equal to the potential energy we just found for point B, 28.126, plus KE. And then if you solve for KE by subtracting 28.126 from both sides, you're going to find that the kinetic energy at point B is 57.09 joules. And that is the answer to part A of the problem. So part B of the problem asked, how much work does the kinetic frictional force do during the BC segment of the trip? So as we can see from this diagram here, which is the same that we had previously, the segment BC is right here, and we're trying to find out how much work the kinetic frictional force does during that segment of the trip. So in order to do that, we need to remember that work is equal to the change in kinetic energy. And so we're trying to find this from point B to point C. So this is actually pretty simple because work would equal the change from kinetic energy, so the kinetic energy in B, kinetic energy in C minus the kinetic energy in B. So the kinetic energy in C is 0 because it comes to rest, as it said in the end of the problem. And then we just solve for the kinetic energy in B, which is 57.09. And then, this is really easy, just negative 57.09 joules. That's all. Good luck in your physics solving adventures.